Our blue planet, a shimmering oasis in the vast cosmic desert, is dominated by water. This precious liquid, essential for all known forms of life, blankets our world in a deep, azure embrace. Oceans, immense and deep, cover over 70% of Earth's surface. These vast bodies of water are teeming with life, from the tiniest plankton to the largest whales, creating a complex and vibrant ecosystem. They hold 97% of our planet's water, a staggering 1.3 billion cubic kilometers. This immense volume of water is crucial for regulating our climate, supporting marine life, and providing resources for human civilization. Imagine the Pacific Ocean, the largest of them all, stretching from California to China, a liquid expanse so vast it dwarfs the continents. Its depths are home to mysterious creatures and unexplored territories, a true frontier of our planet. Yet in the grand cosmic scheme, even this colossal volume pales in comparison to the sheer scale of the Sun. Our star, a massive sphere of incandescent gas, is the powerhouse of our solar system. Our star, a blazing ball of hydrogen and helium, holds 99.86% of our solar system's mass. This immense gravitational force keeps the planets in orbit and fuels the nuclear reactions at its core. It could swallow 1.3 million Earths whole. The Sun's sheer size and mass are almost beyond human comprehension, a true giant in the cosmic arena. The Sun's energy, a relentless nuclear furnace, bathes our planet in light and heat, the very source of life itself. This energy drives the weather, powers photosynthesis, and sustains the delicate balance of our ecosystem. Now, imagine a thought experiment, a cosmic what if. What if we somehow managed to transport all of Earth's ocean water and hurl it into the heart of our star? This scenario, while purely hypothetical, invites us to ponder the unimaginable. It's a scenario straight out of science fiction, a testament to the boundless possibilities of human imagination. Such an endeavor would require technology far beyond our current capabilities, a leap into the realm of the extraordinary. Let's dive into this hypothetical cosmic cocktail, exploring the scientific realities and consequences of such an audacious undertaking. What would happen to the Sun? How would it affect our solar system? These questions push the boundaries of our understanding and challenge us to think beyond the ordinary. The first hurdle in our cosmic experiment is a logistical nightmare of astronomical proportions. How do we even begin to move an ocean's worth of water across 93 million miles of space to the Sun? Even with our most advanced rockets and spacecraft, the task seems insurmountable. Imagine the sheer number of trips, the energy required, the logistical complexity of coordinating such a monumental effort. The reality is, we don't possess the technology or resources to accomplish such a feat. It would be like trying to empty the Pacific Ocean one teaspoon at a time. The energy required to overcome Earth's gravity, escape its atmosphere, and then navigate the immense gravitational pull of the Sun would be astronomical, far exceeding our current capabilities. But let's suspend disbelief for a moment and imagine we somehow overcome this seemingly insurmountable obstacle. Let's say, through some advanced, yet-to-be-discovered technology, we manage to transport all of Earth's ocean water to the Sun's doorstep. What happens next? The Sun, a churning inferno of nuclear fusion, exists at temperatures and pressures unimaginable on Earth. This massive ball of gas, primarily composed of hydrogen and helium, undergoes constant nuclear reactions at its core, producing an immense amount of energy that radiates out into space. Its surface, a roiling sea of plasma, burns at a scorching 5,500 degrees Celsius. This plasma, a state of matter where electrons are stripped from atoms, creates a dynamic and ever-changing landscape of solar activity. Now, imagine pouring billions upon billions of tons of water onto this fiery inferno. What would happen? Would the water cool the Sun, or would it simply evaporate in an instant? The answer in short is not much. The Sun wouldn't even blink. The sheer scale of the Sun's mass and energy dwarfs the relatively minuscule amount of water we'd be adding. To put it in perspective, the Sun's mass is about 333,000 times that of Earth, and it produces energy at a rate of 3.8 x 10 circumflex 26 watts. The water molecules, upon entering the Sun's atmosphere, would be instantly vaporized, their hydrogen and oxygen atoms stripped apart by the intense heat and pressure. This process would occur so rapidly that the water would barely have time to exist in liquid form. The hydrogen atoms, now free, would be absorbed into the sun's existing hydrogen supply, while the oxygen atoms would likely combine with other elements or be expelled into space. This process, while dramatic in its own right, would be like throwing a single ice cube into a raging bonfire. It might sizzle for a moment, but it wouldn't extinguish the flames. However, there might be a slight, almost imperceptible change. The addition of extra hydrogen could potentially fuel a very tiny increase in the sun's energy output. This increase would be so minuscule that it would be virtually undetectable from Earth. Imagine a microscopic flicker on a giant spotlight. It's a change, but one that would be virtually undetectable from Earth. The sun's immense energy production and vast size mean that any additional hydrogen from the water would be a drop in the ocean, so to speak. The sun's energy output is already so vast that even a slight increase would be negligible. The sun has been burning for about 4.6 billion years and will continue to do so for another 5 billion years, with or without the addition of water. So, while the idea of pouring water onto the sun is fascinating, it ultimately serves as a reminder of the sun's incredible power and the vast scales at which it operates. The sun remains an awe-inspiring force, a testament to the immense energy and complexity of our universe. While the sun might shrug off our watery assault, the consequences for Earth would be nothing short of catastrophic. With all its oceans gone, our planet would be transformed into a barren, lifeless wasteland. The blue marble we call home would become a brown, desolate husk. The most immediate and devastating impact would be the complete eradication of all marine life. Oceans, teeming with a diverse array of ecosystems, would vanish, taking with them a significant portion of Earth's biodiversity. From microscopic plankton to gigantic blue whales, all would perish. But the consequences wouldn't stop there. The absence of such a massive amount of water would have a devastating ripple effect on Earth's climate and atmosphere. Oceans play a crucial role in regulating our planet's temperature, absorbing and distributing heat around the globe. Without them, Earth's climate would become chaotic and extreme. Imagine scorching deserts spanning continents, once fertile lands transformed into arid wastelands. The delicate balance of Earth's ecosystems, meticulously crafted over billions of years, would be shattered, leaving behind a desolate and unforgiving world. The disappearance of Earth's oceans would undoubtedly have consequences beyond our planet, albeit minor ones on the grand cosmic scale. The gravitational balance of our solar system, while incredibly stable, is constantly in flux, with each celestial body influencing the others. The removal of such a significant mass from Earth would cause a slight, almost imperceptible shift in the gravitational pull on nearby celestial objects. Imagine a cosmic game of billiards, where the removal of one ball slightly alters the trajectory of the others. These gravitational ripples would be most pronounced on our closest celestial neighbor, the Moon. The absence of Earth's oceans would slightly alter the Moon's orbit, causing it to drift ever so slightly further away from us. The change, while measurable, would be far too small to be noticeable to the naked eye. The broader impact on the rest of the solar system would be even more negligible. The sun, with its immense gravitational dominance, would remain largely unaffected. The orbits of the other planets might experience minuscule perturbations, but nothing that would disrupt the overall harmony of our cosmic dance. Our thought experiment, while firmly rooted in the realm of the hypothetical, serves as a stark reminder of the delicate balance that makes life on Earth possible. It highlights the interconnectedness of our planet's systems and the profound consequences of disrupting them. While the idea of pouring Earth's oceans into the sun might seem like a far-fetched scenario, it underscores the very real threat posed by our own actions here on Earth. Climate change, driven by human activity, is already causing significant changes to our planet's oceans and atmosphere. Sea levels are rising, ocean temperatures are warming, and weather patterns are becoming more extreme. The consequences of inaction are dire. We must act now to reduce our impact on the environment and preserve the delicate balance of our planet. We are all passengers on this spaceship Earth, and it's our collective responsibility to ensure its continued habitability for generations to come. The cosmos, in its vastness and wonder, offers a unique perspective on our place in the universe. It reminds us that Earth is a precious and fragile oasis in the vast cosmic desert, a pale blue dot teeming with life in an otherwise seemingly barren expanse. Let us cherish and protect our home, for it is the only one we have. Our planet is home to a myriad of ecosystems, from lush forests to vibrant coral reefs, each playing a crucial role in maintaining the balance of life. These ecosystems are not just beautiful to behold, they are vital to our survival. Forests act as the lungs of the earth, absorbing carbon dioxide and releasing oxygen, while coral reefs support a vast array of marine life. However, human activities such as deforestation, pollution, and overfishing are putting immense pressure on these natural systems. The loss of biodiversity and the degradation of habitats are not just environmental issues, they are existential threats to humanity. But there is hope. By embracing renewable energy sources like solar and wind power, we can reduce our reliance on fossil fuels and mitigate the effects of climate change. Sustainable practices in agriculture, fishing, and industry can help restore the health of our ecosystems. Communities around the world are coming together to take action. Environmental activism is on the rise, and global cooperation is more important than ever. From local cleanup efforts to international agreements, every action counts. We owe it to future generations to leave behind a planet that is not just habitable, but thriving. Imagine a world where children can play in clean rivers, breathe fresh air, and marvel at the wonders of nature. This vision is within our reach, but it requires collective effort and unwavering commitment. As we look at Earth from space, we are reminded of our shared humanity and the common destiny that binds us all. Let us rise to the challenge and take meaningful action to protect our planet. The time to act is now, and together we can make a difference.